Alright, I think we're coming back with another short stream today. Looks like we're up on YouTube. Trying something slightly different with my stream setup, and I'm not 100% sure Twitch is going to come online, so I'm watching that a little carefully right now. I had been running into this problem with the transcoding server here, where it would very frequently kind of get into the state where the NVIDIA transcode, or the NVIDIA H.264 encoder was no longer initializing, and I'd have to reboot. So I got into a habit of rebooting that machine before each stream, and I think I've upgraded it sufficiently that I hope I'm not hitting that problem anymore. And it looks like it's working. So welcome to folks on Twitch. I'm glad that transcode's working out all right too. So yeah, kind of cold here and kind of tired, and I'm still feeling, man, so on our last stream I was debugging this LED issue, and it actually turned out to be something really embarrassingly simple. It was a firmware bug, so we were initially looking for the problem on the Rust side, and of course it wasn't there. It was a firmware bug that affected the area between the UDP packet with the pixel data that we received and the padding that the firmware generated. And of course it turned out the padding was just in the wrong endianness. The endian was wrong, so it was word swapped. Every 32 bits was incorrect. And yeah, it took me way too long to realize that that was the problem, but then fixed that and fixed a couple of adjacent bugs that we weren't actually hitting, but we could have hit pretty easily. Like, I think if we ended up like padding the packet for any reason and sending any partial pixels, then I wanted to discard that, so we ended up doing that too. And also erase any pixels that are left over in the frame buffer from a previous packet. So made some general improvements to that firmware, and now the LEDs are happy on the flyer. Yeah, it's dark now. Maybe I can actually point this over there. Oh, we have some Indian debates already. I'm happy with either Indian, really. I just need to think about which one I'm using, and in this case I wasn't really. So yeah, I haven't actually edited the LED code since the end of the last stream. It's still running that very simple fade thing. But it looks better than the bug, for sure. Yeah, the LEDs are happy. The winch LEDs are happy. The winches did not seem to have a long enough LED strip to actually hit this bug. Although, next time I update the firmware on them, they'll get the fix as well. So, yeah, so I don't have a ton of time on this stream, but I did want to at least briefly try to look at this issue with the gimbal roll. So the gimbal is powered off right now. It's just like looking up at the mount. But I'm going to power it on, and so it's possible that we might not see the exact same manifest problem, because I've had the gimbal powered off. It's possible that, maybe if the bug involved uninitialized SRAM or something, then it may be that maybe that manifests differently, or we don't see it. The other thing is I'll be powering it on with the flyer over in the middle of the room instead of over here at my desk. So over here it's so close to the edge of the room that it was actually tilting somewhat extremely. So I've got two theories as to why the gimbal was turning on the last stream with this really extreme roll. And I think it's been doing it for more than just the last stream. I think it's been doing that for the last couple of streams. So, and the roll seems to be different depending on the yaw axis, so whatever the problem actually is, it's probably happening in a slightly different coordinate system than just that one motor. So if we do get into reverse engineering, that probably means it's on MCU2, since that's the one that handled all the like IMU coordinate system kind of stuff. Ominous AI overlord you look. Yeah, pretty much. I mean, I hope that with the animations I can make it look a little bit different, but yeah, I'm planning on having patterns that track the camera, so imagine just like a little red dot that kind of follows you around the room to being your little camera wingman dude robot thing. Yeah, so actually someone suggested on Twitter recently that I make it look like Wheatley from Portal, like the Orby robot things. Yeah, that would be neat. I do actually have a plastic sphere that might be about the right size, but if I mounted it just around the whole bottom of that, then it would cause a bunch of reflections and would probably mess up the laser sensor as well. And if I don't think I could mount something directly to the gimbal because that would just be too heavy. But yeah. Well, I'm gonna hit the button and try turning on the gimbal. I might have to help it because it'll often get into a state where the lens is kind of stuck up against the yaw motor. So let's see what happens if I press this button. It needs help. Oh, sorry. Getting in front of the camera right at the best moment. Alright, that is still rolling. Can we get some more light on this? Oh, that's great. Just a little bit more light. Oh, that is kinda seasickness inducing. Poor gimbal. So there are a few routes we could go in. I'm actually lucky enough to have a spare gimbal here, thanks to a generous donation, and we used that a while ago to fix the calibration. We can also use that if we need another gimbal to sort of prototype changes that we might want to make, or test other scenarios without having this whole bot contraption attached to it all. But this works alright as long as we don't care if anything is tilted. But yeah. There are a few routes we could take, so we could try to reproduce the scenario on that spare gimbal. Oh, the gimbal's gotten a little buzzy right now. Yeah, so it also has this unstable region, which is a bit hard to stay out of really reliably at the moment. That's why I want, there are other issues in the issue tracker involving noticing when we've entered some kind of unstable region, and then just actually trying to fix it so it doesn't do that. Both of which are independently probably things we want to do. So yeah, we could take that approach and kind of experiment with the other gimbal. Oh, did we just see the laser? Getting a little distracted. I thought I just got a good shot of the laser aiming into the camera. Maybe not. Another approach, we could just try to understand how the firmware works a little bit more than we have right now. We can do that by reverse engineering. We've already been just kind of disassembling the firmware and try to make sense of what this gimbal does and what the configuration space is used for. Yeah, see that? It's got some internal roll control loop which settles fairly slowly to a value which seems to be calculated based on the yaw, as far as I can tell. So experiments like this help. Looking at the disassembly might help. The thing that I think might be the easiest thing to do next, and which of course would combine well with the other approaches later, is to look at the configuration / status memory space in the gimbal using the tools that we've already written. And this is actually a relatively new thing that we added to the web interface on the bot, and oh man, I occasionally feel weird about we, because there's always a varying amount of group effort. Some things it's like, this is definitely something we did together, and some things it's like, I just wrote this between streams, whatever. And so, I don't know, it's nice to include folks, but I don't want to be disingenuous about it, so it's I have to catch myself evaluating that every time. At least that's the way it seems sometimes. But yeah, I think the first thing to do maybe is to just use that new tool in the web interface to graph some of this data and try to find to just like get a sense for how the roll axis is configured, because I've largely ignored that axis so far. Like, I reverse engineered bits and pieces of the control loop for the other axes in order to figure out how to give them inputs, but I haven't really looked at roll at all. And so maybe with a combination of looking at those values and the disassembly and some intuition from playing around with this, we'll be able to figure out what's going wrong and fix it. VJ asks if it could be the motor failing. I really doubt it. It's not a strength issue. It is holding very firmly in that specific position. Like, if I push it with my hands, it pushes back to get to exactly where it is right now. So it's not an issue of the strength. It might be something being miscalibrated with the motor, perhaps. That's certainly possible, but it's acting more like something is just not initialized with respect to the roll axis control loop. So that's another thing to look at is there are some values that the Windows software was setting every time it would initialize the gimbal and turn the motors on. And I don't think the current code is doing that. So it could just be a matter of using that as an entry point and saying, let's reset that value and see how far that gets us. So I think that's actually number 2 on my list. First is like, let's just look at the values and get a sense for what's going on and maybe write down some more labels. And then let's look at that trace that I've saved of the Windows software initializing it before powering on the motors and see if those values might lend some more light on what's going on. And maybe we can even just like manually set those values and see if that has the desired effect. So yeah. Oh, am I failing to actually reload the YouTube chat page? I don't know if I'm actually getting, if I just leave the browser open between streams, the status seems to be right, but I don't know if it actually connects to the chat server. But it looks like I'm back on YouTube chat now. Sorry if I missed anything. Yeah, actually, I'm feeling like I really need to get a drink. I forgot to prepare my tea, and I'm super dehydrated, so I'll be right back, but I'll try to leave you with an interesting shot of that robot. Maybe turn on a little bit more light here. Looks a little better. Yeah, you can see it just rolls. That's the camera. Right. I can totally stand in front of it. Oh, nice. Nice to see you, Signal Ditch in YouTube chat. And Sean's offering a test. Nice to see you too. Okay. Oh, that's a good question. Ryan asks, is the gimbal's notion of up purely relative to its mount? No, its notion of up should be relative to the accelerometer in the section nearest the camera. So, like, the way the control loops seem to work is at the shortest time scale, they seem to be just kind of funneling values from the gyro sensing angular rates right back into the kind of commanded angular rates for those motors. So at the shortest time scale, they're just trying to counter whatever motion they can effectively. But then they have other behaviors at longer time scales. Like at the point in the control loop where I'm interacting with the yaw and the pitch axes, at least, I'm giving them a value which is kind of an additional commanded angular rate. So I imagine that it gets added to the values from the gyro at some point, but there might be some filtering or coordinate system transformation in there that I haven't actually looked at yet. But yeah, as far as the pitch axis, it's got another higher level control loop that tries to point it relative to the horizon, which I had to disable since the way it was implemented was not really easy for me to send new control values to. So that was part of the binary patch in the firmware for the gimbals. I disabled that control loop among, I mean, that's not the only thing it does, but it was like the pitch rate control loop. So I'm responsible for that, but like I don't actually want to aim relative to the horizon. I'm happy to either lock position or do relative positioning, neither of which require the pitch or yaw axis to know about where down is. So really it's just the roll axis that needs to know where down is. And I haven't reverse engineered how that part works yet. I know that the individual axes, so just to rehash the system a little bit, the gimbal here is an off-the-shelf Feiyutech Mini 3D gimbal that we spent some time reverse engineering and binary patching and physically modifying to get it to this point. And it's got a couple of binary patches in order to make it a little bit easier to control from a remote system like this. There's one that causes it to kind of always boot up in this mode where it's expecting a serial remote control instead of a local joystick. That patch surely has lots of other side effects though, because we're following a very different code initialization path. So there's probably stuff that gets like zeroed out when it gets booted up normally that could be set to a weird, undeterministic value in the way that we're setting up the gimbal. So that's one thing that could be a problem. Let's see. Another patch was to, as I said, remove that pitch control loop because there wasn't a good way for us to actually funnel new values into it. We could have maybe done relative positioning via what would normally have been the joystick inputs, but a stock firmware in that first micro would have actually filtered out the packet that we would have needed to have it like proxy on to the third micro in order to actually have that effect. So yeah, I looked down that path for a while, but it didn't quite work out because that one joystick-ish packet that normally that first micro generates from the PWM signals on the RC servo receiver, I thought it would be able to just forward that packet, but if I remember right, it actually like has a whitelist, and that packet is not included in the forwarding list. So yeah, anyway, back at the roll axis, so I haven't looked into how that control loop works that generates the rate for the roll. That's something that we might have to dig into. What I would expect it to be doing is, so like that settling motion we saw, let me see if I can bring it back. So if I spin this on the yaw axis, where is, oh, right. Oh, that's a good demo, maybe. Yeah, so I spin it on the yaw axis, and now you're seeing it settling on the roll axis. So that first spin was due to my own like command coming from this micro, or from this controller, and from the microcontroller on that robot. But then that secondary motion with the roll, I think what was going on is the robot itself was moving, and/or somebody was doing coordinate system transformation based on the current pose. That was probably happening on microcontroller 2 and coming back through the internal bus back to the roll micro, which is micro 1. So yeah, micro 2 is the one with the IMU, the accelerometer, and the gyro directly attached. So that one is going to be, I think, responsible for generating whatever values the roll loop is using. But then the roll control loop itself, that code I would expect to find on MCU1. And I've looked into that controller the least because I expected it to be the least interesting. I've done some reverse engineering in IDA with on the yaw and pitch microcontrollers, because the yaw microcontroller is the first one, and so it's responsible for the external inputs, and the pitch microcontroller is the last one, and so it's connected to the inertial sensors. But I hadn't really looked at the middle one much. But that's a great question. Let's point this back at something that makes a halfway decent photograph. Let's go to the, I don't know, some kind of computer. It's always annoying for me to actually get the data onto the right computer. Let's just do this from the Windows machine. I don't like doing a lot from the same machine that's actually running everything else because it bogs down sometimes, but in this case it's annoying not to. So this is the bot server. I could just copy this URL. Oh, Vijay is asking about Radari 2/Cutter. I don't know what Cutter is. I like Radari 2. I've used it a little bit. I've been meaning to get more familiar with it, but I got sucked into Radari 2 just a little bit in the past because it's actually really great for like binary patching. You can write little scripts that modify a binary, and that's really nice. I've been meaning to get better at it for just binary analysis, but I'm still not really there. I don't really know my way around it yet, but it's a great tool. I would recommend looking into it. It's just, it is a steeper learning curve than IDA, and a lot of people know IDA and have a hard time learning Radari, but it's worth learning at least a little bit of because it is useful for some things that IDA isn't so useful for, like just doing really quick hex dumps and disassemblies and incorporating into shell scripts and patching and stuff like that. I mean, you can script with IDA, but that's like a different experience. Oh, Cutter is a new UI for Radari 2. Oh, I'll have to look into that. That sounds great. I was not familiar with that. The Tinkering Corner says it would be cool if I could use monofilament fishing line with the winches so it looks like the bot is just flying around. I guess I could do that. I was worried that the monofilament might be less safe if it were to snap suddenly. So like using that around Tuco seems like more of a problem. He would also be more likely to just like bite it and leave weak spots, whereas it mostly comes down to safety. Like I know that the monofilament would probably like look fancier, but it would be more likely to get tangled and more likely to actually hurt someone if it actually got tangled on like Tuco or, you know, a visitor or like a small dog or something. So anyway, so actually this brings you right to this new page, which is, I don't even know if I've shown this on stream. I just added multiple joysticks on here so that I could drive the thing around completely just from my phone if I wanted to. So for example, oh, it's already getting it out of frame. Be toward the camera, away from the camera. So, you know, I don't want to make everyone seasick from starting and stopping the motion so much, but yeah. And then... camera... So, you know, this kind of thing. But what we're here for is the gimbal. Specifically, the internals. Yeah, so the pages here, status is like the nice front page of the gimbal. We have an on-off switch. We have, this is what we're sending to the gimbal to control it. It's like the output of the combination of the computer vision algorithm and the drift compensation algorithm. And if we halt it, then the computer vision's off, and that's just drift compensation. And let's see, and then we have the sensors. These are the actual angles of the joints in the gimbal. There are separate values for the accelerometer, like its orientation, but I'm not downloading those from the gimbal currently. And then hold output. Oh yeah, this is part of the state machine for hold is the drift compensation algorithm here. It tries to just hold a position when we're not actively moving. So I can just move this around. So you can see it goes out of hold and then it goes back in. And that's how that works, and it keeps track of new angles. So that's like, it's like nice high-level stuff. Then there's all the knobs underneath that where you can track or tweak what's actually going on. And we need to spend some more time in here because the tracking could really use to be more dialed in. And I've gone into this in more detail before. There are a couple of different PID control loops that all run at the same time to get the tracking. And there's, the way it's set up right now, there's effectively one that tries roughly to keep Tuco or whatever else the camera's looking at framed, you know, away from the edges by at least like a third, but it doesn't try to keep it exactly centered. And then there's another loop where if the rectangle we're tracking is really pretty far off the edge, or you know, by some amount, it's the amount we're overlapping with a band at the edge of the screen, and that band is you know, this kind of narrow region of high gain. So as the rectangle kind of gets into this larger band that's like a third of the screen, we start panning slowly, and then we get toward this smaller band, the thinner gain region. And so that's, for yaw, for example, we have gain region 0 with width 0.3, which is like a third of the screen, 0.3. Then we have this one, which is like 8% of the screen, which is our high gain region. This is where we would make the pitch tracking faster, but I don't really want to get into tuning this right now. Anyway, internals. This is now much lower level. Now we're looking at the values that are going between... It's actually sort of like this view of shared memory between us and all of the gimbal microcontrollers. So each of these columns is actually one microcontroller in the gimbal. So this is the yaw microcontroller, this is roll, and this is pitch. And that's why right now you can see there's this gap because we're not even talking to the roll microcontroller because we just don't care yet. And so these different columns indicate different usages. So in this case, this is the per joint velocity target, which is the value that we're setting. And red means that we're writing to that value. And then down here, this blue is a value that we're reading repeatedly, and that's annotated as the magnetic encoder position for each joint. And likewise, we're not looking at the roll at all yet. Yeah, Vijay says that's why it's drifting. It's feeling left out. Yeah, I wouldn't doubt it. Although if that micro was crashing, we wouldn't be able to talk to the next one because it is a daisy chain system. LMA says, why didn't I get a gimbal that can look down? This gimbal can look down. The reason it's not looking down right now is because of a bug. So we'll get there. If you want to see the full list of bugs so that I don't have to repeat them all, then I know nobody's actually going to do this, but I'm going to share it just in case. If you go to GitHub, TucoFlyer issues/issues, there's a repository which has its own issue tracker. And this is just all the open issues for the robot. What you are referring to here is fix gimbal buzz/instability, which is what's happening when we get past a fairly narrow pitch range, which is why that's set with a limiter right now. And so once we fix that bug, we can aim the camera much farther down. Mechanically, it can go all the way down. I don't know what realistically we're going to want the limit to be, because I don't think we want to go into gimbal lock. So I don't think we want the software to think about aiming it all the way down necessarily, but mechanically it can do that. So here's the list of bugs I'm going to refer you to when you start telling me to fix stuff that's obviously broken. So let's see. I think the first thing we should do is to start pulling some of these values and see which ones are interesting. So first, I just want to get, oh wait, all parameters with 1 sec is going to eat up all the bandwidth. So you can see the gimbal gets kind of unhappy and drifty as we start eating up all the control bandwidth we have here. So I just like queued up a couple of refreshes and then turned them off. So we should be back to our usual fast self here, but I've got a nice dump of the current values of all these parameters now. So between this and the annotations here, maybe we can pick out some that might be interesting and start polling them more frequently. Specifically, so these are the per joint velocity targets that I'm writing to for the pitch and yaw axes. But I'm curious if this value is sometimes non-zero, because maybe there's another control loop that's writing to this for the roll axis. I don't know if that's how it works, but are we going to get updates for that middle one? I guess it hasn't changed value. It's a little hard to tell the difference between a lack of updates and the value 0 in this case, because smoothie charts doesn't always reliably draw the line if the value min and max are the same. So I might be hitting that problem. I could try editing it. That would help me, maybe. Unintentional extreme focus pull. Oh, something else is writing this to writing 0 to this value. That's good to know. And our graph works. I'm going to see if I can catch the other control loop in action. Do I have enough bandwidth to run the gimbal right now, is the question. Yes. So there I am steering it. That's me steering it in the yaw. That's me steering it in the pitch. I'm going to try steering it and then letting it settle and see if that helps me. See, that is definitely rolling, but I'm not seeing anything on this axis, so no dice there. So I would expect to see some code just like splatting something to that, which is either always 0 or is currently being calculated as 0 for some reason. So that's not interesting. We can turn these off. Okay, what else? Status flags, angular velocity. Don't know much about the units here. Oh yeah, these, I wrote down that these were dynamic. Oh, that's right. So I already did a step here where all of the values that I've seen change at runtime they either have an actual comment description about what's going on, or I just wrote dynamic because the value changes. So Let's take a look at some of those first. A lot of them were up there, but I was curious about the isolated one down here too. Oh yeah, this one also. I annotated that. Unknown. Reset by Windows software prior to motor power on. Right? That one's still zeros though. So maybe this one is superfluous because it's already 0. Follow loop joystick offset. Yeah, no. Oh yeah, and this also makes it easy to take a look at what's going on with the gimbal motors. So this is pretty cool. Yeah, I don't actually know what these values are, hence motor unknown in the comment, but it's something related to either like the velocity or the position of the motor driver. It seems more like velocity, but not quite. Oh, actually, maybe it's current to one of the phases. That would make sense, because you see this sine pattern as I rotate through here. One whole angular velocity. Yes, I agree with the unit assessment. That sounds about right. Chris says it sounds like these Feiyu gimbals might just require occasional roll recalibration. What makes you say that? Is there like a forum post or something? Do they have instructions? Is there like a tool we can look at what it's doing? So yeah, that's pretty neat. Can we maybe look at both of these? We'll be sharing bandwidth between both of these plots, but... Oh. Did it not really rescale those graphs? That's kind of visible. So yeah, they look roughly like inverses, right? I wonder if these are just two of the motor phases. That's the buzzing. You can see it in the motor graphs. Yeah, so I want something to actually detect that oscillation, and it might involve polling these values and looking at the difference between the min and the max at some time period, or maybe something more complicated than that. So it's interesting, but I mostly wanted to show that off. I don't think that's actually what we need right now. But that's something to keep in mind, that we'll want to deal with that soon. Oh, center... No, I mean, that was like the motor calibration point. Quantized velocity related. Let me get my map again. I don't know what this one is. That's really too low level to be especially revealing. This seems to be still kind of close to the motor drive signal. Huh. I don't know. The bumps on the yaw might also just be something related to the magnetic sensor. Like maybe it has some nonlinearities, and so if we're moving at a constant speed, then the power kind of varies due to the kind of bumps in that. But I don't know. Anyway, I still don't know what this is. Let's save this one for later. Just trying to get kind of a cursory examination of these at the moment. Look for signs of that control loop that we're trying to debug. If we can find the control loop in here, then we know which memory addresses to look at in the disassembly if we end up having to go back there. Huh. These are flags, maybe? Always 0 for the roll axis. Integrated IMU angles. So there was a roll over there at 18,000. Yeah, I think I labeled this right. 1/100th of a degree. And so it's got a control loop trying to keep that green value around 0. So that's interesting. Is it that there's some external control loop necessary to kind of zero this against the horizon, and that's just turned off? Yeah, see there we deviated from 0, but there was definitely a control loop pulling it down. So the loop we're looking for reads from this value for sure. So we're looking for something on MCU 1, which reads from 09. All right, let's keep that in mind and move on. There's a bunch of stuff which seems to be just like settings that don't change. So these might be interesting, but they're just like kind of canned values as far as I can tell. Motor control mode. These are, I think, angular ranges. Outer phase offset estimate. Where did this come from? I think, yeah, this is, I don't quite understand what this is for, but this was, I think, one of the lower level parts of the motor controller. Outer phase offset estimate. Oh, phase offset. I think I just meant like the angle at which it's spinning. So I think this is where it thinks the motor is relative to the windings. So I don't know exactly what the difference is going to be between this and like the magnetic encoder values, but I would expect them to be related. Oh, this is within one motor winding. That's interesting, yeah. So you can see like the yaw, I'm spinning it around and it's repeating in that saw wave. Why is it a saw wave? I guess it's just modulo. I mean, if it was actually related to the motor phase, I would expect it. Oh, maybe it's just like linear angle within that. Yeah. So this is probably related to the angle estimates that it gets from like the magnetic sensors, but then converted to be like per motor phase, hence the wraparound. Yeah, I forget why we needed that. I think that was just something that came up when I was looking at the motor controller. And that's very close to the magnetic encoder position, actually. So would we see, does this look like it has like a mathematical relationship to this, where it is just like a modulo? Stair steps here are different. Is this put through another filter, perhaps? Those are very similar. Right? Like that just looks like modulo so far. But at that smaller scale, it looked like maybe there was also some filtering going on, which I would kind of expect. Because the magnetic encoder is very stair-steppy. Like, I think they would want to at least smooth out the aliasing. Anyway, that's not super helpful right now. Oh, do I want to try writing to 09? I don't know if it's actually using this as the integrator or not. So one test would be to see if the... So like one theory is that this is the input to the control loop. So the control loop is, through closed loop feedback, pushing this towards 0. But I wonder if I could also overwrite this, and maybe if I'm lucky, like if I race a few times and write it before the control loop reads it, then the control loop would actually command the gimbal to move. And so I could test that theory by looking closely at the roll while I do that. I hear the gimbal ticking every time I do that. So this is causing the gimbal to very momentarily move sharply and then not. Yeah, that's definitely ticking. It sounds really weird from all the way over here. Well, maybe I just want to go into what reads that value. Just dive right into the disassembly. I would like to... It'd be great if I could find where the output to that is, but maybe it's easier to find that in the disassembly. It's fun poking around in here. I haven't actually like tried twiddling these knobs that much since writing this code. It's also interesting that I would have expected 3 to be the output. So this also makes me wonder, well, like what other processing might be happening to these values? Is that related to the processing that's happening on this value, 9.y or whatever we're calling that? Yeah, okay, let me prep the next step here and get the right VM open with the disassembly. Oh no, don't do that. Roll. MCU1. Sean is linking me to a YouTube video on resetting the gimbal. Could you describe it? Because I don't really want to watch a YouTube video while I'm streaming. Like, just like the gist of it. Is it like a program you download, like a button you push, or like, you know, not that there's like a button on the gimbal, but like, you know, is it like something you do electrically? Is it a tool that you download? Is it like a thing that you do while you're powering it up? Like, I mean, the procedure might be different given the modifications on this gimbal, but that would be an interesting starting point for like what to look for. How did I not give it keyboard focus? Thanks, past me. Okay, this is still my ancient copy of IDA from back when I used to be able to talk my employer into buying such things. Oh, ding. Okay, this is MCU1. It looks like I've already done a little bit of disassembly in here, but maybe not a ton. Have I annotated the parameters at all? Oh, geez, maybe not. Yeah, so I think I mentioned that this micro has had very little attention to it, so I've like annotated almost nothing in here so far. There's a little bit of like ISR stuff. This is the state machine for reading from the serial port. Let me get a little more screen space. Whoa. Full screen ahead. Okay, Sean says 3 ways. Buttons you press on blah blah blah, an Android app. Yeah, I think that's specific to the handheld gimbals. Chris said it looks like you could adjust the calibration using the Windows software. The Windows software did have some calibration. I don't know if it had... Oh, actually, that's a good point. There's actually a different command that... Oh, we haven't actually implemented that. Why did they make that a different command? I'd been meaning to look to disassemble it a little bit just to see why that was a different command, but there's actually another couple of config variables that are stored outside of this config space, and I know there are some calibration values the Windows software can set. I think it's just like pitch and roll calibration, so maybe that's it. Yeah, maybe that's... Thank you. That might be the thread to pull on next. And in fact, maybe we can actually correlate those two and like put that together with this. So I actually do need my notes next to this too. All right. This is back in the FY Gimbal project. This one is also on GitHub if you want to follow along. Oh, not Gimba. That would be a cool name, though. Yeah, so this is not actually part of the Tuco Flyer project. This was something we started beforehand. So scanlime/fy gimbal has some tools for talking to it over serial, just like low-level stuff, the Python decoder. And then the more recent bit of documentation really is really just that the HTML file with the sliders and stuff in that internal gimbal pane. But I've just been putting names in there so far, so that's not really a place for other commands so far. But anyway, in this FY Gimbal project, there are traces that we saved from the Little Windows tool. The Little Windows tool does very little, but I think it does have a little bit of calibration. There was a VM I installed it in. I don't think it was this VM, though. FY Gimbal settings app to internal bus.txt. Yeah, Command D. I'm trying to remember what this Command D was, or how much of this I've documented. So this is like a settings adjustment from the Windows app. This byte here is changing. I think that I thought that was actually, you know, I think this might be just me sending garbage to see how the microcontroller would forward it. Let's look at the simpler trace first. I think that was me doing something weird. Let's look at just the settings example. All right, Command 8. Oh, I need my command cheat sheet. It's just stuff we know so far about the protocol. So Command 8, was that the bootler? Oh no, that's the setter. Okay. So this, yeah, so I didn't really know what was going on here. I was labeling these main and per axis config spaces. That was not actually right at all. So I should update these comments. I think maybe what I meant by main was that those were settings that were maintained by the like, whatever I thought at the time was coordinating the motion of multiple axes. So with what I know now, I would expect that to be MCU2, but I don't think I had any idea where that was at the time. So I think Command 6 and Command 8 are the actual getters and setters we're using now. Let's also just pull up the actual bot controller code now. Because this is going to be the most up-to-date version of the FY Gimbal stuff. Oh, do I just have a really old version of this? I do. Okay, so we've got set value and get value here. That's what corresponds to that table that we were just working through. And that's 6 and 8. So 6 and 8. So 7, if I remember right, that was being used. I've only seen that used so far by that like little angle calibration Windows app. So what is 8 doing here? Do I know what 65 is? Oh, the follow rate, yeah. So I don't care about the follow rate because that code is all disabled right now. I maybe care about that for the roll axis, come to think of it. But I think that's set correctly, and that's in the current param space. Like, it's easy for me to change that from JavaScript currently, so that's fine. I think right now my current focus should probably be on making sure that any of these additional configuration spaces that I can't even reach right now, like where these angle calibration values are, that I actually plumb those through so that I can reach those from the same like gimbal internals page that I was on. So we were saving that. 3 motor power on. Okay, and these are the 7 values, so how did it know where to start this counter? I mean, we could actually run this program on the spare gimbal. It's just not very interesting. We've done that in the distant past, but I'm sure a lot of you don't remember it, and I'm sure we could use a refresher. So maybe we can go back to that. But I'm not that anxious to run the Windows software right now because it's not very useful. So one question I have is, how does, like, it looks like this is sending the actual value, not the increments, yet the way I remember the software working is it has like plus and minus pokey buttons in the UI, and so my curiosity now is, how does it know what value to start this at? In this case, it looks like it started at 0. Does it always start at 0? I kind of doubt it. Where would it be reading that? Is it this? This isn't RX. No, 5 was save, wasn't it? Yeah. So no, that's a confirmation that that was written to EEPROM, so no, that's not it. 3 is the motor power on. 8. Those are both sets. So it's not like right there. Is it somewhere further back? No, we might, I mean, it might have been before the trace started, but Oh, did I restart the Windows app down here? Oh, I restarted the gimbal right here. That's the bootloader. Oh, and then I attached the serial. This is gimbals that have not been patched will send you this serial challenge that you have to answer within a timeout, otherwise they'll move on and turn off the serial port. What do we know about command 9? I didn't mean that. Yeah, I bet command 9 is the corollary to 7. That would make sense given how these are ordered. So command 9 is going to be the getter that returned all those zeros. We issued that to the pitch and the roll, but not the yaw, which makes sense because there's no yaw calibration. Cool. That all makes sense. So... Or no, this was only roll. This was a roll and this is a reply. Where's like a t equals 1? Or no, sorry, no, that's not roll, that's pitch. T equals 1 is roll. Is there another command 9 that I'm missing? Maybe that's off the edge of the trace. I assume command 9 is the getter. I assume that this is the index of the register we're getting, and that these are the value, or are there only 3 values? This is retrieving all of them. Let's take a look at what command 9 does, maybe starting in one of the firmwares that we've done more work in. So let's put MCU1 aside again. And back to MCU0. Oh, OBS is disconnected. Oh, geez. Did we just glitch our stream? Sorry about that, folks. I don't know where that came from, but OBS just complained about a disconnection, so we must have had some kind of momentary glitch. Hopefully we're back now. Let me know if there's... Okay, it's fine. Cool. Slight stutter. Great. Apparently the transcode got restarted at least, but that's fine. So I think we already had labels for the command handlers in here. I don't think we had global labels for them. We'll start at serial 1 poll. So actually, I'm gonna walk through here from like the ground up and show you how we got here. I mean, obviously, it's going to feel like we already drew the rest of the owl because this has a bunch of symbols that I laboriously annotated, but if you ignore the symbols, there's that, and we can go through the process of actually how you get there completely from scratch again in the future, because I'm sure we'll do this again. We have in the past. So anyway, let's start with the interrupt service routines that we're interested in. So go to the beginning of Flash. Was that where our IVT was? So the actual interrupt vector table here is at like not quite the usual location because of the bootloader we're using. But I think it was pretty easy to find. I think it was just the first thing in the file. I just need to actually zoom in a little bit so I can navigate. Yeah. Yeah, 8004,000 is the interrupt vector table that we end up using after the bootloader has gotten into the application. There is a bootloader which handles like daisy chaining the boot sequence from micro to micro, and it does some really simple encryption, and it's not really that interesting to us, so like we know enough about the bootloader to set up the firmware, but that's pretty much it. So then these will map to the interrupt vector. Like if you look up the data sheet for this microprocessor, you can figure out which interrupt vector all of these are. A lot of these I haven't bothered annotating it even. The first several are standard fault and reset vectors that any like ARM Cortex processor is going to have. So this is the stack top, this is the reset vector, then we see some fault handlers, which are mostly just unique infinite loops that'll just stick there so that you can see what happened in the debugger after the crash. And then down here we have a smattering of hardware-specific interrupts, which you can figure out by reading the datasheet for this processor and the nested vectored interrupt controller. So there's the system clock tick. The most interesting thing at the moment is going to be the serial ports. So USART 1 and 3. If I remember right, USART 1 is like the upstream kind of pointing toward the input side. So in this case, on MCU 0, this would be talking to like us on the PC side. It goes through our kind of TI microcontroller and then onto the network. If this were still in a like RC aircraft, usually this would be disabled after boot because we would send a packet to it, fail a timeout. then disable this and instead use the same pins to read pulse width modulated signals. So then USART3 is the other serial port, which in this case talks to the next microcontroller down the line. So if we go to USART1, ISR, follow those links, we'll, if we decode this a little bit, notice that it's not really doing anything immediately, it's just storing the value in this FIFO. And if we look at where the FIFO is being used, we can find this other function that I'm calling serial1poll, which extracts a value from the FIFO, and then calls serial1handleRead. And this function, if I remember right, is actually the state machine. Yeah, so this decodes packets. The packets have a simple framing and header. And yeah, so there are a couple different states here. Handle foreign packet here is a packet that belongs to a different microcontroller, so we'll forward it on to the next. But then, and this code looks a little different in each micro. In MCU 0, the per packet type handler got inlined into this function, so it's especially messy. But MCU 2 didn't turn out that way because it just has a lot more going on, so that function didn't end up inlined. So then these are the actual commands. Command 8 poke, Command B, PC init, etc. So what were we looking for? Command 9. So we know that Command 6 and Command 8 are getters and setters for some kind of pretty interesting, pretty general purpose, like configuration and status space that the micros use. Command 7 and 9 seem to be similar, but for maybe a more special purpose memory space. So it'd be interesting to know what's actually going on there, especially with a getter. We can just scan that memory. This microcontroller doesn't have like bounds checks for the most part, so we need to be careful not to crash it too badly. But I would imagine getters would be relatively harmless. So yeah, Command 9, unknown get, returns 12 bytes. Really? 12 bytes? I wonder if this was really supposed to be 12 nibbles, because I see 6 bytes there. Anyway, I think that's probably 3 16-bit values, but don't know. Command 8 poke. Oh, I wonder if it's actually not implemented on this micro, because this might be something that's only used on the third micro, so MCU 2 in our numbering scheme. So, yeah, I guess that's why I would have initially assumed that there was a per axis and a main configuration space. Maybe that's actually right. Maybe my initial intuition was correct about that. Because maybe that space isn't implemented at all on this micro. Okay, well, let's go over to MCU 2. Yeah, so a main and a per axis config space. I guess that labeling is just weird to me because, like, the main, as far as I can tell, has very little in it. So I wouldn't really call that main anymore. I would call that maybe, like, IMU related or supervisory or something. Whereas the per axis config space is per axis for the most part, but it's also pretty main. Okay, so MCU 2, different binary, same story. Let's go to the IVT. And USART1, follow the link, serial1 FIFO, oops, and poll, handle read. Okay, so this is just the read state machine, and then we have serial1 handle packet. A lot of this is labeled, so we have target MCU, serial command, and 4, 3. What is 4? I don't know what 4 is. No idea what command 4 is. This is a bit of a sidetrack, but there's... Huh. This works with param 59, 5a, and 5b. Storing some new values in there. That could be some kind of new calibration. Oh, now we're into the per axis config space, but some values that are only used by MCU2. That's interesting. And these... So that's got to be some kind of saved calibration. 59 A and B. Okay, that's getting somewhere. That could be related. 59 A and B. It would... I'm actually a little curious if there might even be some correspondence where maybe that other config space is somehow embedded in this one. That wouldn't surprise me that much. Anyway, let's go back up a layer. Let's actually save that because that was a useful change. And we were looking mostly for 9 at this point. Command 7, Command 8, Command 9. So this is the 1 byte parameter. If it's non-zero, we're going there. That's like the garbage case. That's like, we don't actually want this command, right? Yeah, that's just returning without doing anything. So we only really want this byte to be 0. That's interesting. Oh, geez, where's the next instruction here? Oh, yeah. This is all just special purpose calibration stuff. There is no separate config space. Well, that's actually a bit of a relief. Ha 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 ha. Cool. So this is just enforcing that byte is always 0, as if they're planning on adding more cases in the future, but maybe this is just like... So like on the other micros, we found it had this concept of these, in the per axis space, it had this concept of these calibration poses that seemed to be numbered 0 and 1. And so you'd take calibration pose 0 was all the motors centered. Calibration pose 1 seemed to be something else, which I still don't know what that pose actually represents. I'm assuming it's something that's relevant to how the motor windings are actually aligned relative to the magnetic encoders, but we literally just had to copy those angles from a working unit and then run the calibration procedure at that angle. So that was with the per axis config. I'm wondering if maybe there's a similar kind of numbered calibrations idea that the firmware authors had in mind for this micro. I mean, functionally it doesn't matter because there's only one of these. I don't think we need to really worry that much about extensibility given that we're only supporting one model of gimbal right now. But I think the intention here was that there was a 1-byte selector parameter for some future expansion ability or something, but that in practice it looks like they're just dumping these 3 values. So 5C, 5D, 5E. Let's take some notes. 5CD, oh yeah, 5CD and E. Let's make these a little more distinguishable too, because I was trying to make these groups of 3. 5C, D, and E. Returned by command 9. Let's actually save that. And that's all command 9 does. So we can actually document command 9 also. Oh wait, is it all command 9 does? Oh, what is this? No, it isn't going, oh. No, there is more stuff going on. Okay, never mind. I was like, nop, right? No, that's because there's a loop. Yeah, no, the reason I was like, oh, that's it, because it would make sense if it just returned those values, because it returns a 6-byte packet. But, so it's copying these into these temporaries. Then, what is that temporary? This looks like some kind of like mutex. So they're spin locking, or they're like spinning here until this is 0, and then they're setting it to 1. So like this is a critical section of some sort. Wow, and what is... This is interesting. Okay, and then we're headed into the same funnel. What are we sharing this ending with? Because we are going places. What does this function even do? I mean, I was expecting it to be like a getter for some values in memory, not to go off all on this tangent. So we have another kind of spin lock protected thing in Commando 6 peak. Was that the corollary to this, or am I getting that confused with the other one? Yeah, no, Commando 6 is regular get value. Okay, what's going on here? Because in the other micros, that was pretty straightforward. Is there maybe just some post-processing happening that we don't need to look at right now? So let's look at peak, because I think I know how peak is supposed to work. Like, I've used this command a bunch. So it takes an argument with, is it 8-bit or 16-bit? I think in this case it's an 8-bit index. So yeah, that corresponds with this, LDRB. The index is in R0. We're indexing into the param list. This calculates the address of the individual param we want, and that puts it in R0. This acquires the critical section lock, mutex in here. And then it looks like we're starting to build the response. So if we follow this pointer, we get to here, LDRB. This is where we're actually reading the parameter. We read it 1 byte at a time and copy it into this destination pointer here, R1, which, like, this is just building the response packet. Like, this is a packet header. These are, like, this is the framing. These are the header bytes. This is the actual response. Oh, so is that all we're doing here? Maybe I'm just looking at this and being like, it's so complicated because it inlined the packet response building code. That's also a bit of relief. The other micros didn't look like this. The other micros, I think this was a separate function. I don't know why it inlined all of this. Okay, that's fine. Cool, yeah, this is just a getter, and does that match up just right with these values we're saving? Let's be 28, 2A, and 2C. A. I think... I think this is just like the assembler is not picking up on this add, but these are the same values, so that's fine. Let's see if we can. So I think that matches our expectations. I was just getting myself confused with the verbosity of that code. So let's write that down. Did I have, I mean, like, I'd like to add this to the Rust code, but maybe I can focus on just the documentation first. Yeah, so I'm going to call this the per axis config space, and instead of main, I'm going to call this the MCU2 only config space. I think that's a lot clearer. At least I think that's clearer. Who knows? So then this will just read 6 bytes with params FC through FE, or 5C through 5E. I know that's a little vague, but I can document this more thoroughly when I'm actually writing code for it. Yeah, okay, so I think next I just want, yes, this is save per axis config. I mean, as far as I know, there's only one config space here. So I'm just going to try to say that. So command 7. I'm expecting that to be some kind of straightforward write, which maybe selects one of these values and just pokes it in there. So here's command 7. We have a byte and, is that misaligned? Is that a misaligned read? What does this look like in the log? So I'm looking for command 7. You know, maybe this processor allows misaligned. I usually expect ARM processors not to allow misaligned loads, but some of them do. So, or it's possible that it is actually half-word aligned. It might start 1 byte after the boundary. Anyway, it looks like the intention here is a byte followed by a word, if I'm reading this right. LDRB at serial payload, LDR SH payload +1. So I think what's going on here is the byte is a selector and the half word here is the actual value. So I would expect R0 to go into like a switch statement effectively, and then R1 to end up getting stored somewhere. So then that all goes into a subroutine. Looks like the parameters are in the same order you'd expect, like almost as if someone wrote the source code in a sensible way. Oh, that's interesting. Is this some kind of lookup table? You know, I wonder if this is a packed jump table that fits in the registers. Anyway, let's not get too far ahead. So R0 is what I would expect the comparison to be made on. R1 is, well, let's actually write these down. So R0 is the selector. R1 is the value. Oh, is this function maybe to condition the value somehow? It looks like we're wrapping the value in that. So the value is in R0, we call BL, presumably it returns it again, and so we're, like maybe this clamps the value to prevent the client from sending in bad stuff. Commando 7 value prep maybe is a thing to call this. Yeah, this is clamping. Looks like R sub 1056. Okay, so I'm not going to worry too much about what exactly that's doing, but I'm assuming this is to prevent people from hurting themselves by writing crazy values to those registers. And what is going on here? Oh, are we scaling? Like, is this actually like, this might actually be doing some kind of like fixed point multiplication or scaling. What is this? Yeah, I don't want to dig too deep into this because I don't even know if this is relevant code or if this is like math library stuff at this point. But let's keep this in mind. I can't tell actually off the top of my head whether this is fixed point or floating point, but this is definitely some kind of like we're looking at math operations through a little bit of abstraction here. And I would assume it would be fixed point, but this might be a floating point library operation. I don't know. Because like these numbers, these are like literals that they don't look like floats, but I'm not good at decoding IEEE in my head. So yeah, these could be fixed point values, they could be floats, there's some kind of numerical constant. These might be something like floating point multiplication or something, but it's probably more complicated than that, or just different than that. So anyway, we're doing something to prepare the values here, which is worth looking into. And then looks like we're getting ready to write them into param space. And it looks like we're just switching and writing it into 5C, 5D, or 5E. 5C or 5D and 5E? No, it's just splitting this up. There's one comparison here. The other comparison is kind of unrolled into, this is an ARM convention if you haven't come across it, but you can write if then else EQ is what this instruction means. What that means is that the next 4 instructions are now part of a special packed conditional construct, which means you can actually kind of mix these letters. In this case, it reads then, else. So if it's equal, which means if R5 is equal to 1, because that's the last comparison we made that set those flag registers, then these 2 instructions run. Otherwise, these 2 instructions run, which is great. So this is doing exactly what we'd expect and just writing to either 5C, 5D, or 5E. So let's write that down too. That is command 7. very terse description just to try to remind my future self what this value is for. So yeah, Commando 7, write with a numerical transform, which I'm being vague there because we don't actually know what that does. I'm just assuming it's some kind of like fixed point or floating point scaling and clamping operation, because that's what it looks like. And then an 8-bit selector, which seems to be 0, 1, or 2 for 5C through 5E, then a 16-bit value. So, that looks nice. It also looks kind of like I might be able to get away without really implementing these specifically in my tools. Like if we need to do this really regularly, I can see why you'd want one command to just give you all the values, but if we don't mind a lot of bus chatter, then we can read these values by just issuing 6 or 3 separate commands. So, like I don't really see a reason to implement that straight away. But it does seem like 5C through 5E, like we might just try like playing with 5D and see what that does, and like see if we can guess what the units are like. So I don't want to go too much deeper into this without a little more tooling, and I might write some of that between streams because I kind of want to wrap this up soon. But before I go, I at least want to try editing this value 5D, because I think that's what we want. If that is it, we could actually save that into non-volatile memory. I don't have a save button on the gimbal config space because I don't really want one. I don't really want to be writing to the gimbal non-volatile memory a bunch. But we could just like write that like in the JavaScript console. But it might also just be nice to have these config values saved in the bot server YAML config file instead of just in the gimbal memory. So I don't know, we can see about that. Oh yeah, it looks like I'm a little behind on the chat, but Thomas says it looks like an inlined right to the UART. Yeah, I think that was before when we were talking about that like big blob of code that was in the command handler. And yeah, that was just an inlined call to a function that was building a response packet. So nothing fancy there, just a lot of vomit for us to deal with, figure out what that was actually doing. And yeah, I think when I was actually doing the reversing, I was more used to the code patterns involved, and I'm just a little rusty at actually reading all that code right now. So anyway, 5D, no new tools necessary. Let's just go back to the regular old console, which I had open on this machine. Or maybe I closed it. I can get it back. D. So gimbal internals. That is right here. Oh, it's set to 0. Really? I don't believe you, numbers. Let's get a full refresh of all these numbers. They are all 3 set to 0. Well, that's something to try, isn't it? So I would expect 5C not to matter. Like I think if they were being less orthogonal about how this was all constructed, they could leave that one out, because I don't think you ever need like a center calibration of this nature for yaw. I mean, maybe that's true with the way I'm using it, but maybe if the original like factory follow loop wasn't like stubbed out, that would be fine. But anyway, I don't need this parameter. 5D and 5E might both be useful potentially, but really 5D, so let's pull that slowly and edit it. And we only care about MCU2's value here. I have no idea what the units are. Do you see it rolling? I think I see it rolling. Is this wishful thinking? I would think this would be doing something different by now. Be sure that the gimbal is actually on and moving. So that works. You know, I also wonder if, I mean, it's possible that this is how it's supposed to work, but it might be malfunctioning for some reason because I've disabled parts of the gimbal's control loops. I mean, I've disabled some of the control loops and not others, basically. So maybe something that's supposed to be using these values actually isn't. So we do have other avenues to explore this. Like, we are far from at a dead end here. The other thing that I wanted to look into, which we haven't even had time to look at, is that we already know that the control loop we're hunting for is on MCU1, and it reads parameter 09 as an input for the closed loop feedback. And we can just look for that in the disassembly, and we will find it, and we can trace out from there to figure out what else affects it. So I think that's a pretty surefire way to figure out what's going on here. This was just a really interesting aside to track down because, like, you're right, that this is definitely how, like, related to how I think this was supposed to work in the software that came with it. But it's not clear to me that that is actually still working how it's supposed to work. We could try on the spare gimbal, like setting that up without the firmware patches, and then try editing these parameters. I don't really feel like doing the setup to do that experiment, though. I think we'd maybe be more fruitful, first of all, just like looking at the command 09, or the param 09 stuff that I was just mentioning. Let's also try 5E and 5C. I know I just said 5E shouldn't do anything, but let's just make sure. And these shouldn't do anything either. These shouldn't do anything. Big ol' nothing. And this one shouldn't do anything either. Let's try that. I think this whole control loop that would have been reading this value is disabled at the moment too. Yeah, nothing. Alright, well, we have definitely some more leads, nothing entirely conclusive. It's very interesting that the values that are only present on MCU2, like, those are definitely interesting. We've also been looking at these 5.9, 5A, and 5B. I don't think we've actually figured out what these are yet, but it might be interesting to poke at them. And they're non-zero, which is interesting. I'm tempted to just try editing 5A and see what that does. I'm going to turn these off first. So, like, these look like another triplet of values, 5.9, A, and B. No one else is overriding it, but I also don't see any difference. Let's try these two values also. Nothing. And 5B. Nah. Alright, so we need to look elsewhere. That's fine. We have plenty of elsewhere to look. Alright, I think that's coming up to a pretty good wrap-up point for my current stream. I think I should go hang out with Tuco and my other fuzzy loved ones, and not so fuzzy loved ones. And yeah, I hope you get the opportunity to do the same on whatever day you like to do those things. So yeah, nice to see everyone. And yeah, special thanks to everyone who keeps us going. If you like the show, if you tell your friends about it, if you send hardware my way or chuck a couple of bucks toward the Patreon every month, that's all what keeps us going, and I appreciate it. So let me know how I can make this a more interesting experience for you if you have any ideas, because I'm here to make it interesting and educational and just an all-around nice hangout for folks. So that's it. I don't know where Tuco is right now, but I will catch up with him and give him a hug for everyone. And we'll get back to this soon. There's plenty to dig into. I've got an opportunity to write some LED animation code now that we don't have silly bugs getting in the way of that. And there's still some mysteries inside the gimbal, but we're pretty close to having that working better, it looks like. Still a few mysteries in terms of the buzzing as well, so. All right, I'll see you folks next time.